All right, here we're going to finish the example that I was working on in that previous one. We found the lower sum, and now we're going to find the upper sum. If you remember, our function was f of x equal to x squared, and we're finding the area of the curve from x to 2. I want to clarify something that I think I misspoke earlier, where we have a graph here, and I misspoke why we called it the upper and lower sum. I think I had the previous example I did in my head still. All right, so our curve looks like that. The reason why, when we did the lower sum, we did the left endpoints while we used I minus 1, is because the left part of my rectangle was going to be on the graph. That's why it's called left endpoints. All right, so the left part of my rectangle is on the graph. If you notice now, because this is what we did in that last problem, if you notice, my area is going to be less. That's why it's the lower sum. All right, it's going to be, that's the low end of our spectrum. All right, in this case we're going to do the upper sum. So what we're doing, we're looking at both the left and the right endpoints. Now my right endpoint's going to be on the graph. So if you notice, my right endpoint's on the graph. My area that I find is going to be slightly bigger. That's why that's the upper sum. That's why the previous one was the lower sum. Since we're using, for the lower sum, since we were using the left endpoints, that's why we used I minus 1. Since we're using the right end, in this case, it turns out that the right endpoint is the upper sum. We're going to use just I for the upper sum. All right, and if you remember, we found our range, right? We're going from 2 minus 0 all over, and we were breaking it into n intervals, right? So we're breaking it into n intervals, so my intervals are going to be 2 over n. And we said that our endpoints is going to be 0 because we're starting at 0. All right, that's where we're starting. That's the far left we're starting, plus 2I over n, right? That was going to be our endpoints. So where we're starting here now is 2I over 1. So if we have intervals of just of 2I, all right, or of 2 over n, all right, we're breaking into n intervals, all right. When we put this into a summation, we're going to say f of 2I over n. So if I choose 1, I'm at my first point. If I choose 2, I'm at my second point. All right, so if I choose I equal to 1, I'm at my first point. I equal 2, I'm at my second point, and so forth. All right. So if we remember, right, when we plug it into the function, that was going to give us our y value. That was going to give us our height of our rectangle. And then we needed to take that by our width, which is always going to be 2n, because we're breaking these into our difference here was 2n. All right, 2 over n. All right. So now we need to figure this summation out. So we're taking the summation of f of 2I over n times our width, which is 2n. All right, so let's go ahead and let's plug our 2I over n into the function. So we're going to have the summation, and don't forget my n on top here, I equal to 1, and when I plug 2I over n into this equation, I get 2I over n squared, and I need to take it still times by width, which is 2 over n. When I square this, this is going to become 4I squared all over n squared. You square every term in there. All right. Now I take it times 2n. I'm going to have 8n cubed I squared. Remember when we were taking summations, we have all those formulas to what the summations of the i's equal. We wanted to get rid of the n's and the other variables and the other constants and stuff like that, because we know formulas for what I is equal. What I equals, we know the summation of what I equals, the summation of I squared, I cubed, and all that sort. So let's go ahead and let's pull an 8n cubed out. So I'm going to have 8 over n cubed. We're going to pull that out and do the summation when I equals 1 of n. And all that's left is just I squared. Well, if we look back at our formulas, we know that our summation of this is going to be, of I squared, is going to be n times n plus 1 times 2n plus 1 all over 6. All right, we're multiplying these together. All right, so we're multiplying these two together. We might as well cancel this out and become a 4. This becomes a 3. All right, so if I pull that out, I'll have 4 over 3n cubed times n times n plus 1 times 2n plus 1. The next logical step then is to FOIL all this stuff out and then simplify, right? So when I do that, after I FOIL all that stuff out, I'm going to get 4 over 3n cubed times 2n cubed plus 3n squared plus n. And all I did here was I FOILed all that stuff out and combined like terms. All right. Then let's go ahead and let's multiply our 4 over 3n cubed by everything in this parentheses here. And we're going to find that our upper sum is going to be 8/3 plus 4n plus 4 over 3n squared. And that's not too far off from what we did last time. I think there was a minus sign in there. I believe this was a minus sign or something like that in our last example when we found the lower sum. They're not too far off. And actually what we find out is that if we take the limit of both our upper sum and our lower sum, if I take the limit as x approaches infinity, all right, this 8/3 stays the same. This infinity, something over infinity becomes 0, and this is going to be something over infinity that becomes 0 as well. We're going to get 8/3. And it turns out when if we would have taken the limit of our lower sum, if you have that written down, you can go take the limit as n approaches infinity. All right, you'd get 8/3 as well. And from that, what we decided, or what came out of that, is the limit set, or the theorem 4.3, the limit of the lower and the upper sums are always going to equal each other. As long as continuous, non-negative, is on an interval from a to b, since we were from 0 to 2, that was our interval, and the limits are going to equal each other, all right, the limits are going to equal each other no matter what. So basically what it's saying is we only have to do either the upper or the lower limit. We don't actually have to go through all that work and do both of them. My suggestion is to use the right endpoints where you just have to use I. That is my suggestion for that, because it's just so much easier when you have the I minus 1. The second example there was so much cleaner. But I suggest that you use the I formula, or the right endpoint one. So basically you only have to do that once, unless they tell you to find both the upper and the lower sums. Then you actually have to find both, which we did in these last two examples there. I hope this helped, and we'll see you in class. Have a good weekend.